down, the first concept that we teach is set, right? It is very basic thing in the math. And sets basically, they help you to define relation and functions. So whether I want to go ahead and I want to do relations or I want to do functions, for everything set is very important. ठीक है जी? Now, even when you want to do geometry, sequences, probability, हर चीज के लिए set is very important. So set theory is the base of math. Now, sometimes, although it is not very important, but people may ask, ma'am, who discovered or who developed the concept of set, right? So, because we should know this theoretical information also, that the theory of set was developed by German mathematician George Cantor. So, we have a German mathematician. The name of the German mathematician was George Cantor, and he lived from 1845 to 1918. And he is the one who first developed the concept of sets. So, sets. So, kab develop hua? When did he develop it? So, very interesting story. Okay. So, he was working on trigonometric series. Okay. And why? You can read the story if you want to. It is a good idea to read these stories. जब आप पढ़ते हो ना कि लोगों ने कैसे कुछ डेवलप किया, उससे आपको और encouragement मिलती है और motivation मिलती है. So he was the one who was working on some trigonometric series, and while working on trigonometric series, he thought of sets, right? So imagine the mind that goes behind the development of things, how these people go ahead and they develop these things, right? So better now I want to go ahead and I want to start by talking about what is a set. Okay. So the question that we are asking today is, what are sets? सबसे basic question यही है कि set होता क्या है? So whenever we go ahead and we do collection of items. Now, these collection of items can be anything. Collection of cards, collection of a cricket team, collection of natural numbers, maths mein, collection of prime numbers. Whenever we go ahead and we do collection of things, that is called a set. Okay. Let me give you an example to what a set is. So to give you an example, like for example, I can say collection of odd natural numbers. Less than 10, let's say. ये एक set बन गया ना? What are the odd natural numbers less than 10? 1, 3, 5, 7, 9. So these odd natural numbers which are less than 10, that is a set. Let me take another example, beta. Collection of rivers of India. Can you name some rivers? Ganga, Yamuna, Brahmaputra. So if I go ahead and collect all the rivers in India, that is also a set, right? Now, the third thing. Collection of vowels in English alphabet. So, beta A, E, I, O, U. ये जो भी vowels हैं, if I collect them, that is also a set. Collection of various type of triangles. So beta, if I go ahead and say isosceles triangle, equilateral triangle, if I collect different kind of triangles, ये भी एक set है. ठीक है? Now, let me give you more example. Prime factors of 210. तो बेटा अगर मैं किसी भी चीज के प्राइम फैक्टर क्या होते हैं? जो भी चीजें आर अ मल्टीपल, जिसको जब मैं मल्टीप्लाई करूं आई गेट 210. जैसे फॉर एग्जांपल बेटा, एंड दे शुड बी प्राइम नंबर्स नाउ. ठीक है? सो फॉर एग्जांपल आई नो दैट 210 can be written as 21 into 10. But beta, neither 21 nor 10 is a prime number, right? 21 can be written as 3 into 7. 10 can be written as 2 into 5. So 210 can be written as 3 into 7 into 2 into 5. बेटा ये चारों के चारों prime number है. These are all prime numbers. So the prime factors of 210 are 2, 7, 3 and 5. Is this clear? So collection of prime factors of a number will be एक set है. Then F. Take another example. Solution of equation. Just for example, if I go ahead and I say, Acha, what is the solution of x square minus 5x plus 6 equal to 0? What will you tell me, beta? It will be x square minus 2x minus 3x plus 6 equal to 0. So I take x common, x minus 2, take minus 3 common, x minus 2 equal to 0. So क्या आ जाएगा बेटा? X minus 3 into x minus 2 equal to 0. So this implies या तो x will be 3 या x will be 2. Either x will be 3 or x will be 2. So beta, the collection of the solution of the equation, that is also a set. अब clear हो गया set क्या है? Collection of items, collection of objects of a particular kind, that is called a set. And all these that we did today, these are examples of set. Now, I want to talk about sets used in maths. So when we talk about the set used in maths, symbols हैं जो हम maths में use करते हैं. There are some symbols that we use in maths. तो बेटा वो कौन से symbol हैं जो हम maths में use करते हैं? The first example is N. N stands for all natural numbers. The second is Z. Z stands for all integers. The third is Q. Q stands for all rational numbers. ठीक है जी. The fourth is R. R stands for all positive. Positive लगाने की जरूरत नहीं है. Actually plus मैंने लिखा ना. So all real numbers. Then the next is Z plus. Beta देखो, Z is all integers. Now when I put a plus sign here, then Z plus is all positive integers. Then beta I have Q plus. So Q was all rational numbers. So Q plus beta is all positive rational numbers. Right? And R plus. So beta R was all real numbers. So R plus will be all positive real numbers. So ध्यान से देखो, what have we done? N stands for all natural numbers. Z stands for all integers. Q stands for all rational numbers. R stands for all real numbers. Then Z plus stands for all positive integers. Q plus all positive rational numbers. R plus all real numbers. But I will be using this throughout my maths classes. जो भी हम पढ़ेंगे आगे, मैं ये symbols का throughout use करने वाली हूँ. So it is very, very important that you go ahead and you learn these symbols. ठीक है जी? Now, but next we want to understand that a set is not only a collection of items, but now I want to use very important term. A set is a well-defined collection of items. Well-defined word use करना बहुत जरूरी है. What is well-defined, right? So try and understand, beta. Well-defined क्यों use कर रहे हैं हम word? If it is not well-defined, then it is not a set. Let me give you an example. Suppose I go ahead and I say, give me the name of top 5 renowned mathematicians. सबसे अच्छे जो mathematicians हैं, उनके मुझे नाम बताओ. Give me name of top 5 renowned mathematician. What will you tell me? You will tell me, ma'am, I don't know. Why? Because, for me, the best mathematician may be very different from what you think is the best mathematician. है कि नहीं? Similarly, I may tell you, give me the name of top 5 cricketers, top 5 actors. You would tell me the same thing, ma'am. I don't know why. But for me, the best actor may be Shah Rukh Khan. But for you, the best actor may be Ranveer Singh. Are you getting it? For the third person, it may be someone who is not even from Bollywood, maybe from Hollywood, maybe from Tollywood. We don't know. So if I tell you, give me the top 5 actors, it is not a well-defined collection. ठीक है, समझ में आ रहा है? So we want that it should be a well-defined collection. It should be defined properly. Jैसे vowels. Whether I ask you about vowels or whether a third person tells me, सब लोगों के लिए vowel same ही है, A, E, I, O, U, right? But सबके लिए top 5 actors same नहीं है. People don't have the same top 5 actors. So well-defined is very important. I hope this is clear to you. Second thing that I want to highlight. With an object की जगह पे many books will use elements. Many books will use members. Objects, elements, members, these are all synonymous to each other. इन सबका एक ही मतलब है. They are not different things. They are the same thing. So please understand that object, element, and members are synonymous to each other. Next. But whenever we talk about any set, a set is always defined by capital letters. इसको हम लोग small letters में नहीं लिख सकते. We don't write it in small letters. So it is usually denoted by capital A can be a set, capital B can be a set, C can be a set, and so on. So they are denoted by capital letters. Okay? But the elements of the set, they are denoted by small letters. So A, B, C, X, Y, Z. These are elements of the set. Elements को हम small letters से denote करते हैं. Let me give you an example. Suppose I tell you, give me the 5, give me the, let me make the set by the first 5 alphabets. Okay. So you can tell me that my set name is set A, and this set A consists of A, B, C, D, and E. First 5 alphabets. तो ध्यान से समझो. Capital represents the set, and elements are represented by the small. I hope this is clear. Okay. Then we also want to understand that I have something which is this, because this represents belongs to. So this is a Greek alphabet. It's a Greek symbol, and this symbol means belongs to. It's a Greek symbol and it means belongs to. Similarly, beta जब ऐसे लिख देते हैं, this means does not belong to. So we have belongs to and does not belong to. Clear हो गई ये बात? जैसे for example, ध्यान से समझना. Suppose I tell you that एक set है A, and this set has first 5 numbers. So this set is 1, 2, 3, 4, and 5. But now I'm asking, does 4 belong to this set? So you will tell me 4 belongs to A. Now I'm asking, does 7 belong to this set? So you will tell me, beta 7 does not belong to A. ठीक है जी. So इसका मतलब हो जाता है belongs to. 4 यहाँ पे है ना, 4 is present, right? And इसका मतलब हो जाता है does not belong to, doesn't belong to. I hope this is clear. Now, there are 2 methods of representing a set. So a set can be represented using 2 methods. The first method is called roster or tabular format. This is tabular. Okay? So the first form is called roster or tabular form. And the second form is called a set builder form. So a set can be represented in 2 formats. एक set को हम 2 format में represent कर सकते हैं. The first is called a roster or a tabular form, and the second is called as a set builder form. पहले हम समझते हैं what is a roster form. So whenever we write it in the roster form, Then in this format, beta, everything is written in these curly brackets, right? जो भी elements होते हैं, they are represented in the curly brackets and they are separated by comma, right? And let us take an example. Just say, if I ask you, give me a set of all natural numbers which divide 42. So beta 42 के क्या क्या natural numbers हो सकते हैं? What can be the natural numbers that divide 42? 1 into 42, 2 into 21, right? 3 into 14, right? 6 into 7. So beta, these are the numbers which give you 42. So if I have to write in the set format the numbers which divide 42, कौन-कौन से numbers हैं? 1, 2, 3, 6, 7, 14, 21, and 42. And I can name this set. This set is called set A. So I can say that set A represents all natural numbers which divide 42, and I can represent set A like this. I hope this is clear better. Okay. Now, please understand that in when I talk about the roster format, when I list the elements, we say that all elements are listed, right? And in this case, we say that the order is immaterial. थोड़ा समझ लेते हैं क्या मतलब है इसका. So when I say order is immaterial, it does not matter whether you write it in ascending order, descending order, random order. इससे कोई फर्क नहीं पड़ता. So I just have to mention all numbers which divide 42. So my set could very well have been beta 1, 3, 6, 2, 14, 7, 42, 21. ये भी वही set है. I am including all numbers here also. So the order does not matter. It does not matter which order you will write it in. It just matters that you should be able to go ahead and write all the numbers which divide 42. ठीक है बेटा? Similarly, suppose I ask you write in the roster format and give all vowels in English. So you can represent that set by B, suppose. So B is that set which has all vowels. कौन-कौन से vowels हो गए बेटा? A, E, I, O, U. These are the different vowels that you have. ठीक? Similarly, odd numbers, etc. Now, note that whenever you go ahead and you write a set, very important thing, in the roster format, you should go ahead and have no repetition. Not repeated. Elements should not be repeated. Let me give you an example. Just say, if I ask you, make a set of all alphabets that come in the word school. SCHOOL. So make roster form of all elements which come in the word school. तो बेटा क्या करोगे? S is coming in school, C is coming in school, H is coming in school, O is coming in school, and L is coming in school. Even though O is coming twice, doesn't mean you will repeat it. You will write it only once. सिर्फ एक बारी लिखना है. अगर O repeat भी हो रहा है तो भी एक ही बारी लिखना है. Are you getting it? So my set will have all elements coming only once. You only write unique elements. ठीक है? तो हमने कौन से दो चीजें सीखी हैं roster form में? In the roster form, we learned that one, you should only be writing unique elements. Repeat नहीं करना है. And second, that the order is irrelevant. Order does not matter. So this is called the roster format. I hope this is clear to you. But now we want to go ahead and we want to talk about the set builder format. In set builder format, we need to go ahead and we need to write it in the crisp manner. Okay? And how do we write it? Just for example, if I say that, let's say that V is a set representing all vowels. So I want to write a set V, and this V should have all vowels. How will I write it in this set builder form? Okay, ये question है. So beta, I will write it something like this. V is the set. इस set में क्या है? Elements. So X is an element of V. And what should X be? It should only be a vowel. The common property is that it should be a vowel. So X such that this dot represents such that. So X such that X is a vowel in English alphabet. So beta, when I write it like this, that is called the set builder format. ठीक है, एक और एग्जांपल लेते हैं. Supposedly, I tell you that I want all elements in the set between 3 and 10. All elements that lie between 3 and 10. ठीक है. Now, how will you write it in the roster format, beta? So in the roster form, I will write that there is a set A. And what is this set A? Beta, this set A consists of all elements between 3 and 10. Matlab, I will have 4, 5, 6, 7, 8, 9. That's it. So this becomes my set in the roster form. Now I'm asking you, how will you write this in the set builder format? In the set builder form. So let's write it. So I'm saying, beta, I have a set A. What is this set A? I need to have all X's, all elements, such that X is a natural number. X must be a natural number, and I want this to be between 3 and 10. So this is a set builder format. क्या कर रही हूँ मैं इसमें? I am saying I want all X's such that X is a natural number and X should be between 3 and 10. So this becomes your set. I hope this is clear to you. ठीक है? Now I will give you some questions and let us practice those. So question number 1 for the day. Write solution to x square plus x minus 2 in roster form. You need to write this solution in the roster form. ठीक है, करते हैं. Let's solve this. So beta, x square minus plus x minus 2 equal to 0 can be written as x square plus 2x minus x minus 2 equal to 0. Take x common, x plus 2. Take minus 1 common, x plus 2 equal to 0. X minus 1, x plus 2 equal to 0. So x will be 1 or x will be minus 2. या x1 होगा या minus 2 होगा. So in the roster format, there are only two elements that x can take, 1 and minus 2. So this is the roster format. Roster, I've written the set in the roster format for the solution to this equation. एकदम clear हो गई ये बात? This is my answer. Now let me give you one more question, beta. So please write down. Write the set X is such that X is positive integer and x square is less than 40 in roster form. In roster form. ठीक है बेटा? So I want that x square should be less than 40 and x should be a positive integer. Negatives include nahi karne hai in the roster form. So 1 square is 1, so 1 can come. 2 square is 4, so 2 can come. 3 square is 9, so 3 can come. 4 square is 16, so 4 can come. 5 square is 25, 5 can come. 6 square is 36, 6 can come. 7 square is 49, 7 cannot come. तो बेटा ये हो गया इसका आंसर in the roster format. I hope this is clear. This is the answer in the roster format. Okay, beta. Come to the next question. Question number 3. Write the set A is equal to 1, 4, 9, 16 in set builder form. Take lete hain. So what are we saying? We need to write 1, 4, 9, 16, 25 and so on in the set builder form. But clear hai, this is just square of natural numbers, na? So I can say A is what? It has elements x such that x is square of natural numbers. So I want x such that x is going to be square of the natural number. Yahi wo set A hai. This is clear to us. Or now I will write it in a better format. Jaise maths mein aap dekhoge kaise? I can say A is containing elements x such that x is nothing but it is square of the natural number where this n can only be natural number. समझे? देखो एक बारी जरा. A consists of elements. Elements have to be written with small alphabet. That's the first thing I taught you. Such that these elements are square of the numbers. And these numbers can only be natural numbers. We have represented it mathematically. Right? Acha beta. Now, please go ahead and do the next question. So, write the set 1 by 2, 2 by 3, 3 by 4, 4 by 5, etc. till it goes till 6 by 7 in set builder form. Please do it. Now see. Dekho, denominator is 1 more than numerator. That's the first thing. Then what do we see? We see that both numerator and denominator are naturals. And it can only go till 6 by 7. So how can we write it? Define a set. Let's say the name of the set is B. It has elements x such that x is number divided by number plus 1. So n upon n plus 1. Okay? Where n can only be natural number. Beta, integer to nahi aa rahe, negative numbers to nahi aa rahe, sirf natural numbers aa rahe hain na. So n can only be natural number. And beta, n can go from 1 to 6 only, na? Isn't it? 6 ke upar to set nahi defined hai. So n can only go between 1 and 6. This is the answer to this question. So we have written this in the set builder format. Is this clear? Very, very important concept. You should, this is the first thing. Ye nahi aayega to kuch bhi nahi aayega. Right? So beta, this is what I wanted to do with you today. Now, what you should be doing is I am giving you homework. Right? And you should be doing this homework and then you can go ahead and come in the next class and I will talk further about set theory. Okay? So, please write the following in the roster format. Right? So first, A is such that x is such that x is an integer and x is between -3 to 7. That's the first question. Second, f is such that we have the set of all letters in the word better. You have to write the two in the roster format. Okay? Second question. Write it in the set builder form. What's the question beta here? So first, A is a set which is 1, 4, 9 till 100. And second, B is a set which is 2, 4, 8, 16 and 32. Write these two in the set builder format. In the last class, we had talked about two forms. दो form हमने set के पढ़े थे. One was called as the set builder form and the second was called as the roster form. ठीक है जी. But today we will continue with the set theory, and what we are going to talk about is going to be the concept of empty set. So the topic of the day is empty set. That is what we are going to begin with. For your reference, you can go back to the previous lecture where we started talking about the set theory and we talked about the set builder format and the roster format. I had also gone ahead and given you homework. It will be a good idea if you do the homework on the same day. Okay, beta. Now let us talk about empty set. So, beta, what is an empty set? An empty set is set which does not contain any element, right? For example, I say A is a set. And how do I define it? I define it by the number of students. And I'm saying X is such that X is a student studying BA and MA economics. But this is not possible now that the student is doing both BA and MA at the same time. He will either be doing BA or MA, but he cannot go ahead and he cannot do both the things at the same time. So beta, this set is an empty set. So a student cannot simultaneously be doing both BA and MA. Therefore, A is a null set, right? Or an empty set or a void set. तो null set, empty set, void set तीनों का मतलब एक ही है. Any set which does not contain any element is called this. So beta, how do we represent this now? It is represented like this. और तो set को हमने ऐसे curly bracket से represent किया था ना. अब अगर उस curly bracket के अंदर मैं कुछ भी ना डालूं, if I don't go ahead and put anything, that means it is empty. So a null set or an empty set or a void set can be represented by this or it can be represented by this. ठीक है बेटा? Okay. So let us go ahead and take few examples of empty set. Take the first example, beta. Example number 1. Now, for this example, I am saying the following. I am saying let A be the set such that X is such that X is between 1 and 2 and X is a natural number. तो बेटा natural numbers क्या होते हैं? 1, 2, 3, 4. ठीक है, ये natural numbers है. Now X is not, now in this interval that I have written, it is not including 1. 1 से बड़ा होना चाहिए. Not including 2. 2 से कम होना चाहिए. मतलब 1 और 2 के बीच में होना चाहिए. तो ऐसा कोई नंबर जो 1 और 2 के बीच में है ना, पर natural number है तो possible नहीं है, because natural numbers are 1, 2, 3 and so on. So beta, this becomes an empty set. Acha beta, take the next example. B. X is such that X square minus 2 is equal to 0 and X is a rational number. ठीक है बेटा, when I go ahead and I say x square minus 2 is 0, what does this mean? इसका क्या मतलब है? इसका मतलब है कि x square is equal to 2. So x will be plus minus root 2. So there is no rational number that satisfies this equation. किसी भी rational number के लिए ये equation satisfy नहीं हो रही है. So this implies that this is in fact an empty set. Clear है बेटा? अच्छा, third. C. X is such that X is an even prime number greater than 2. बेटा जैसे ही हम कोई भी इवन नंबर लेते हैं ग्रेटर देन 2, 4, 6, 8, कोई भी इवन नंबर ले लो, it will not be prime, it is composite ना, because 2 will be one of the factors of it. ठीक है, so जैसे for example सिर्फ 2 एक ऐसा प्राइम नंबर है जो इवन है ना, so 2 के फैक्टर्स हैं 2 and 1. But whenever you will write any other even number like 4, उसके फैक्टर्स हो जाएंगे 2, 1 and 4. Like 6, उसके फैक्टर्स हो जाएंगे 2, 1, 3 and 6. So the only number which is even and prime, beta, that will be 2, right? So this becomes an empty set. Let's come to the next example now. D. D says x is such that x square minus 4, but x is odd. Then beta, this is also an empty set. Q, because if x square minus 4 is 0, then x square will be 4, then x will be plus minus 2. So x will be plus minus 2. So beta, this is even, x is not odd, so this is incorrect. ठीक है जी, clear हो गई एकदम बात. Now let's come to the next concept. I hope null set is clear to you. Now I will talk about finite and infinite sets. So beta, when I say finite sets, as the name suggests, finite should have finite number of elements in it. Just for example, I define a set A, and this set A is x is such that x is first 5 natural numbers. So beta, this is a finite set क्योंकि x की सिर्फ पहले 5 natural numbers की ही value आएंगी 1, 2, 3, 4 and 5. But when I talk about suppose B is suppose vowels A, E, I, O, U. So again beta, this is a finite set. ठीक है, तो A is a finite set, B is a finite set. But अब एक example लेके देखो C. And I'm saying C contains all the men living in different parts of the world. But this is not finite. This is infinite. I don't know how many people are living currently in this part of the world. If I start naming them, this will be an infinite set. So beta, finite contains finite number of elements and infinite contains infinite number of elements. Clear hai ye baat ekdam? Okay. Now, how will we define this? So please write down the definition with me. A set which is empty or consists of a definite number of elements is called finite. तो बेटा बहुत बच्चे कंफ्यूज हो जाते हैं कि मैम नल सेट क्या है, फाइनाइट या इनफाइनाइट? बेटा उसमें तो एक भी एलिमेंट नहीं है. So it has to be a finite set, right? So any set which is empty or it contains definite number of elements is called a finite set. Otherwise, infinite, right? Otherwise, it is an infinite set. Or examples kuch le lete beta. So take these examples. So the first example is that W is the set of days of a week. So beta, days of weeks are fixed. There are 7 days in a week. So W is a finite set. Take the next example beta. So when I say S is set of solution to equation x square minus 16 is equal to 0. So beta, when I write down this equation, x square minus 16 is 0, x can take only finite values, plus minus 4, hai na? So x is going to be plus minus 4. So beta, that again means that it is a finite set. But let's say that G is a set of points on a line. But now I don't know how many points are there on this line. Can I count it? I cannot. I have this also as a point on 9, point on 9, point. So I cannot count the number of points on the line. So beta, that is an infinite set. I hope the difference between finite and infinite set is clear to you. Clear ho gaya beta? Okay. Any infinite set cannot be represented in the roster format because elements do not follow any particular pattern. सिर्फ finite set को ही roster format में लिख सकते हैं, infinite set को roster format में नहीं लिख सकते हैं. If you want to understand what is roster format and set builder format, we did it in the last class. Please refer to the last class. Okay, beta. So we please write this down for me that all infinite sets cannot be described in roster form, right? Because elements don't follow any pattern. For example, set of real numbers cannot be described in the roster format. ये possible नहीं हो पाएगा कि हम real numbers को roster format में define करें. और बेटा set builder format में भी, जैसे for example, the set of natural numbers. But this is infinite. Natural numbers तो infinite है ना? अगर मैं बोल देती set of first 5 natural numbers तो वो finite हो जाता. But set of natural numbers in itself ये तो infinite है ना? So infinite को हम कैसे दिखाएंगे? 1, 2, 3 कहाँ तक लिखती जाऊं? It is infinite. So how do you represent it? You represent it dot, 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 dot. These dots represent that it is an infinite set. Acha, by the way, I just kept doing dot, dot, dot. Actually, you follow it by exactly 3 dots. The right pattern is to follow it by exactly 3 dots. This means that it is an infinite set. समझ गए बात को? Clear है एकदम? अच्छा, अब क्वेश्चन करते हैं एक बात बेटा. So, state whether it is finite or infinite set. ये बताना है कि क्या ये finite है या infinite है. ठीक है जी. पहला एग्जांपल लेते हैं बेटा. X belongs to natural numbers and x minus 1, x minus 2 is 0. X is such that x belongs to natural number and x minus 1, x minus 2 is 0. So beta, in this, we know that this implies either x is 1 or x is 2. So x can only take 2 finite values. So beta, this is clearly a finite set. It cannot be infinite. ये finite set ही हो सकता है ना? अच्छा, take the next example. Second example. We are saying x is such that x belongs to natural number and x square is equal to 4. But clearly this is also a finite set Q, because if x square is 4, this implies that x can either be plus 2 or minus 2. Minus 2 cannot be included. Integer include nahi karna hai, sirf natural number include karna hai. So I will not take minus 2, only plus 2. But this is automatically a finite set. So my set will be only including 2. Clear ho gaya? Okay. Now come to the third example, beta. So when I say x is such that x belongs to natural numbers and 2x minus 1 is 0. So beta, इस case में क्या होगा? देखो 2x minus 1 0. What does this imply? It implies x is half. But half is not a natural number. Natural number should have been 1, 2, 3, etc. So therefore, ये जो set बनेगा ये एक null set होगा. It will be a null set. Either represented like this or like this, right? So beta, since it is a null set, we know that this is still finite. Therefore, finite. It is a finite set. Take the next example, beta, fourth example. X is such that x belongs to natural numbers and x is prime. So x belongs to natural numbers and x is prime. But there are infinite prime natural numbers, right? So you start with the natural number set, but it is infinite ना. एक बहुत बड़ा natural number हो सकता है जो किसी भी चीज से divisible ना हो. So it will be still a prime number. Are you getting it? So beta, this is an infinite set. So infinite set, right? Last. So I'm saying that fifth example, beta, x is such that x belongs to natural numbers and x is odd. इसमें क्या होगा? Beta, there are infinite odd numbers. 1, 3, 5. ऐसे करते जाओ. बहुत सारे odd number आ जाएंगे. 1, 2, 3, 4, 5, 6, 7, 8, 9 is also odd. इतना बड़ा number जो बनेगा. ठीक है? So there are infinite odd numbers. So this is again an infinite set. Clear हो गई ये बात? Now come to the next topic, beta. So that is called an equal set. So beta, now we want to go ahead and we want to talk about equal sets. Two sets, A and B, are called equal if every element of A is in B and every element of B is in A. So please write down. A and B are equal sets if every element of A is in B and every element of B is in A. Take example लेते हैं. So beta, let's say that A is 1, 2, 3 and 4. And beta, B is 3, 4, 2 and 1. A का हर element B में है और B का हर element A में है. So beta, when every element of A is in B and every element of B is in A, we will call them as equal set. Is that clear? So this is when you have equal sets. Achha, take another example and tell me whether they are equal or not. Now what I'm doing is I'm saying A is beta 1, 2, 3 and beta I'm saying that B is 2, 2, 1, 1, 1, 3, 2, 1. Are these equal or not? The answer is yes. Beta, set contains unique elements. Set से जब हम निकालते हैं कंपैरिजन के लिए तो हम यूनिक एलिमेंट्स को निकालते हैं. We do not repeat any element. So बेटा that ways if I check B में कौन से एलिमेंट्स है नॉन रिपीट या यूनिक 1, 2 and 3 और A में भी यही एलिमेंट्स है 1, 2 and 3. So ideally A and B are equal sets. Clear हो गया? Okay. Now बेटा let us take some questions. So please write down. Find the pair of equal sets, if any. ठीक है. So please go ahead and take it. So the first one is A is 0. B is such that X is such that B is equal to, sorry. X is such that X is greater than 15 and X is less than 5. C. X is such that X minus 5 is equal to 0. D. X is such that X square minus 25 is 0. E. X is such that X is an integral positive root of the equation X square minus 2X minus 15 is 0. So you have to go ahead and you have to tell me that out of these 5 sets, beta, which sets are equal sets. ये बताना है कि कौन से sets equal sets हैं. तो करना शुरू करते हैं बेटा. Second देखो. So X has to be greater than 15 also and less than 5. ऐसे तो possible नहीं है ना कि एक ही वो नंबर हो जो 15 से बड़ा भी हो और 5 से कम भी हो. It is not possible. So we know that B is a null set. B is a null set. Clear हो गया? अच्छा, come to अच्छा, A is containing the element 0. बेटा A is not null. ये बहुत बच्चे confuse हो जाते हैं. A is not null. A contains an element and that element is 0. But B has come out to be a null set. अब C देखो. C says X is such that X minus 5 is equal to 0. So बेटा if X minus 5 is equal to 0, this implies X will be equal to 5, right? So C has an element which is 5. Ab D dekho. D says X is such that X square minus 25 is 0. So beta, tell me something. If X square minus 25 is 0, doesn't this imply that X square is 25? Doesn't this mean that X will be plus or minus 5, right? So from here, we know that D contains two elements, plus 5 and minus 5. Is this clear? It contains plus 5 and minus 5. And lastly, it says E is such that X is an integral positive root of this. So beta, your equation given to you is X square minus 2X minus 15 is 0. X square, so 15 is 5 into 3. So minus 5X plus 3X minus 15 is 0. X minus 5 plus 3. X minus 5 is 0. X plus 3. X minus 5 is 0. Either X is minus 3 or X is 5. So beta, there are two elements in this. E contains two elements, which is nothing but it contains minus 3 and 5. So what do we see? Anything that we see? There is just one thing left for me to do here. Note that this says it is integral positive root. So I cannot take the negative element. So I have to eliminate the negative element. Now it was asking which are equal sets. So beta, इनमें से कौन से equal दिख रहे हैं हमें? Clearly we can see that only C is equal to E. Otherwise, none of them are equal to each other. Only C is equal to E. Clear हो गया? Okay. Now, beta, come to the next question. I am giving you this as a homework. Please try to do this on your own. So you have to tell me which of the following homework, which of the following are equal sets, right? Which of the following are equal sets? So एक लिख लो जरा first part इसका. So first, X is the set of letters in alloy, right? And beta B is set of letters in loyal. You have to tell me whether these are equal sets or not. Okay, next question likho, second. N is such that n belongs to Z and n square is less than equal to 4. B is such that X is such that X belongs to R and X square minus 3X plus 2 is equal to 0. So you have to tell me whether A and B are equal sets or not. Okay, beta. Now, in the last class, we had gone ahead and we had talked about finite and infinite sets and equal sets. And we had also done some questions on these. हमने finite set, infinite set, equal set. इन सब पे कुछ questions भी किए थे. आज की क्लास में हम इसको थोड़ा कंटिन्यू करेंगे और आज हम बात करेंगे फर्दर सबसेट्स की. So today we will start by talking about subsets. But when it comes to subset, what is a subset? A set is said to be a subset. So let's write down the definition first. A set A is said to be subset of set B if every element of A is also an element of B. तो बेटा सबसेट क्या होता है? एक सेट A को हम B का सबसेट तब बोलते हैं जब A का हर एलिमेंट B में प्रेजेंट हो ही हो. So when will I say that A is a subset of B? Only if an element that belongs to A, ये belongs का साइन होता है, ये सबसेट का. So A is a subset of B if element that belongs to A also, it implies that that element definitely belongs to B. तो जो एलिमेंट A को बिलोंग करता है, अगर वो एलिमेंट B को बिलोंग करता ही करता है, then A is a subset of B. Beta, let us take some examples to it. Example number 1. Let us say that we have a set Q. And this set Q is rational numbers. Q represents rational numbers. And let's say that we have R. And beta, we know R represents real numbers. Beta, rational plus irrational real number होते हैं. तो यहाँ पे आ गए मेरे rational, irrational number दोनों मिलाकर real number. So rational number is a subset of the real number, isn't it? So we can say that Q is a subset of R. Beta, second example देखो. Suppose I say that A is a set of all divisors of 56. And I can say that B is a set of prime divisors of 56. So beta ध्यान से समझो. When I will write the divisors of 56, 2 into 28 is 56. 28 ko I can write 2 into 2 into 14. 14 can be written as 2 into 2 into 2 into 7. So when I say prime divisors, if I have to make a set of prime divisors, prime divisor will only be 2 and 7. If I have to make divisors of 56, क्या क्या 56 को divide करता है? 2, 7, 14, 28, 1, 56. These are all divisors of 56. So beta, this is a big set. This is a small set. So I can go ahead and say that B is a subset of A. I can say B is a subset of A. Clear हो गया subset का concept? अच्छा, एक example ले लेते हैं. So now I'm giving you this example where I'm saying that consider the following set: null set. Another set is A is 1, 3. Another set is B. B is 1, 5, 9. And another set is C. C is 1, 3, 5, 7, 9. So beta, as you can see clearly, you should first know that a null set is subset of every set. Null set हर set का subset होता ही होता है. A null set is a subset of every set. So which means that beta, null is a subset of B, null is a subset of A, null is a subset of C. ठीक है? अब देखो क्या A B का subset है? नहीं. Because A contains 3 which is not there in B. So A में A, 3 is an element, 3 belongs to A, but 3 does not belong to B. So A is not a subset of B. A is not a subset of B. बेटा क्या A C का subset है? Yes है, because इसमें सिर्फ 1, 3 आ रहा है और इसमें ये 1, 3 present है. So बेटा A is a subset of 3 and that is true. Is that clear? Okay, now let us go ahead and let us talk about some more examples. So what I can say is, beta ye hote hain natural number, right? We know that natural number is just 1, 2, 3, 4, 5 and so on, right? And then I have integers. Integer is negative and positive numbers together. So beta, I can say natural number is a subset of the integer. Now integer plus, so integers are only numbers which have denominator 1. But any number with any other denominator becomes a rational number. So beta, we can say that rational number ka subset jo hai ye, integers are a subset of the natural rational numbers. So rational numbers, it will come here. Try to understand. Natural numbers are only 1, 2, 3 and so on. Integers include negative and positive, all. So this entire thing is belonging here. So natural number is a subset of integers. Now Q, which is rational number, is any number that can be represented in P by Q form and Q is not equal to 0. तो बेटे सारे integers को मैं P by Q form में तो लिख ही सकती हूँ 1 by 1, 0 by 1, minus 1 by 1. But I can have other numbers also, 5 by 6, 7 by 8. So beta, ये जो हो गया integers, it is a subset of the rational numbers. Now, after rational numbers, we have something which is known as irrational numbers. So let T represent irrational numbers. Beta, rational and irrational together form real numbers. So we can say that rational number is a subset of real number. Rational number वो सारे number जो P by Q form में लिख सकते हैं, that is a subset of real number. And irrational number is also a subset of real number. And finally, we can go ahead and say that जो ये relationships हैं, इनको अगर हमें final एक obvious relationships बनाने हैं, so you can write the following. First, natural number is a subset of integers. Integer is a subset of rational number. Rational number is a subset of real number. Irrational number is a subset of real number. Clear हो गई है बेटा? ये sometimes it can be asked in exam. You should be clear about it. ठीक है? Now, I want to go ahead and I want to talk about intervals. So we will talk about intervals now. In intervals, we have two kind of intervals, beta, closed and open. So we have closed interval and we have open interval. Take an example. If I have this number line and I write here A and B, I want to include everything between A and B, but not A, not B. A और B को include नहीं करना, but A और B के बीच में जो भी है, वो सब मेरे को include करना है. Then my interval will be A, B, but it will be open. So I'm talking about all numbers between A and B, not including A, not including B. Beta second. Second आता है हमारा supposedly I have A here and B here. ठीक है. I want to include both A and B also. So I want my interval to be such that I want to include both A and B. So beta, how will I write this? I will say my interval is A, B and both A and B are included. So X is between A and B, including A, including B. Then it is called a closed interval. इसको बोलते हैं closed interval. I am including the endpoints also. Better take example number 3. Now I have to only include A, but I don't want to include B. So beta, I want to include A, but I don't want to include B. So X is between A and B, but A is included and B is not included. ठीक है. एक last example देखते हैं. Example number 4. So beta, now I am saying that A and B, I want to include B, but I don't want to include A. So A and B. I am including B, but I am not including A. These are your intervals. The difference between this, beta, upper minus lower, upper minus lower. The difference between upper and lower, that is called the length of the interval. So B minus A, that is called the length of interval. Right? Clear हो गई ये बात? अब हम आते हैं एक important aspect पे, जिसे बोलते हैं universal set. So what is a universal set? A universal set is usually denoted by U, and this universal set basically, in particular, this is basically, as the name suggests, it is the biggest set possible. ठीक है? जैसे for example, let me give you an example. जैसे for example, for the set of integers, universal set can be rational number. So अभी हमने prove किया बेटा that integer is a subset of the rational numbers. Integer is a subset of the rational numbers. So rational number will act as a universal set, bigger set for the integers. Clear हो गई ये बात? Real number is a universal set for natural number, rational number and integer. क्योंकि सब कुछ चाहे natural हो, integer हो, rational हो, irrational हो, कोई भी number definitely real number तो होगा ही, क्योंकि real तो rational plus irrational है, समझो. So when I say real number includes rational also and it includes irrational also बेटा, है ना? It includes rational and irrational. Rational अपने आप में includes integers. Integers अपने आप में includes natural number. So कोई भी number हो, whether it is a natural number, integer, rational or irrational, ये सारे ही number real तो होंगे ही होंगे. So real number is the biggest set. Are you getting it? So we can say that this real number beta becomes the universal set. Real number set, the biggest set is the universal set. Clear हो गई है बात? So beta, this completes a big topic, a big chunk of the topic of set theory. Now, I want to go ahead and I want to do one more topic with you today, so that set theory का काफी part खत्म हो जाए. And this is known as Venn diagram. So let's start with that. So now we want to start with Venn diagram. In Venn diagram, I want to go ahead and I want to first show you a representation of Venn diagram. So for example, let's say that I draw a universal set, and this universal set is 1, 2, 3 till 10, right? And now I tell you, I want to draw a set A. Set A is a subset. I told you everything has to be subset of the universal set. So set A is subset of the universal set, and set A has only even numbers, 2, 4, 6, and so on. So beta, how will I show this? This is how I will represent it in the Venn diagram. This represents my universal set, this box. The universal set has all elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is my universal set. It has all elements from 1 to 10. But now I want to represent a subset of the universal set which only contains even elements. So to show a subset, I will draw a circle. And I will say that this A, this is a subset of the universal set. So beta, through this, I can say that A is a subset of U. This is what we have proved. A is a subset of U. Is this clear? This is how you can show a universal set and a subset. Now let us do some operations on set. In order to perform operation on set, we need to go ahead and we need to understand some basic things. And the first thing that you want to do is called a union of the set. So let us try to understand what is union of a set. Union of a set means that you will, so just say if I want to do A union B, then beta A will include all elements of A. This has all elements of B, and union means addition. So when I will get the final set, it should have both elements of A and B. So union symbolically means addition. You will include all elements of A and all elements of B, but remember, there should be no repetition. So only unique. Let us take an example. Suppose I tell you that A is 2, 4, 6, and 8. And I tell you that B is 6, 8, 10, and 12. But now I'm asking you what will be A union B. A union B means you will take all elements of A, all elements of B, but no repetition. So A में क्या क्या आ रहा है? 2, 4, 6 and 8 आ रहा है. B में क्या क्या आ रहा है? 6, 8 already ले चुके हैं. So take 10 and take 12. So this will be A union B. So A union B means that you will take all elements of A and all elements of B, but no repetition. But let's name this A union B as C. Look that A is a subset of C, because जो भी A में आ रहा है वो C में है ही है. So A is a smaller set, C is a bigger set. A is a subset of C. Similarly, beta, B is also a subset of C. I hope this is clear to you. Now, let us go ahead and take another example. Okay. So, supposedly, I tell you that X represents the students of class 12th. Okay. And I have Ram, Geeta, and Akbar. Samajh mein aaya? Then beta, I also want to include students of class 12th only, but who play football. So Geeta, David, and Ashok. These students, they play hockey. These play football. And now I'm asking you to find all the students of class 11th. Okay? So what you can say? You can say X union Y will be Ram, Geeta, Akbar, David, and Ashok. These 5 students. How will you interpret this? These are those students, या तो वो हॉकी खेलने वाले बच्चे हैं या फुटबॉल. So in English I can say either hockey or football. बेटा ऐसे भी तो बच्चे हैं जो दोनों चीजें खेलते हैं, जैसे गीता, right? So or both. So this set union represents either A or B or both. जो दोनों भी खेलते हैं वो भी हम include कर रहे हैं. So the definition, mathematically, definition of union can be that union of A and B contains all elements which either they belong to A or B or both. And in the Venn diagram, it can be represented with either वो सिर्फ A में है or B. And ये कोई common area ना A और B का, or either A or B or both. There are some properties of the union that you should be knowing. So please write down, beta. Properties of union. The first property of union is that whether you do A union B or B union A, it is the same thing. This is called as commutative law. So just take an example. Suppose I have A as 1, 2, 3, 4 and B as 3, 4, 5, 6. So beta A union B means all elements of A and all elements of B but no repetition. Beta B union A करके देख लो. All elements of B and all elements of A but no repetition. एक ही बात तो है. So A union B or B union A is the same thing, and this is known as the commutative law. Let's do the next one. This is known as associative law. So beta associative law states that whether you do A union B and then do a union with C, or you first do B union C and then do a union with A, it is the same thing, right? Take an example. So suppose I have A as 1, 2. I have B as 3. And I have C as 4, 5. So beta A union B क्या होगा? All elements of A and B, 1, 2 and 3. Now if I do इसका union with C, so जो भी elements इसमें है plus इसके elements, it will be 1, 2, 3, 4 and 5. Now revert it. If I find out what is B union C, so all elements of B and C, so it will be beta 3, 4 and 5. And then now I want to do its union with A. So A union B union C. मतलब जो B union C मिला है उसका union A के साथ. So beta it is going to be 1, 2, 3, 4 and 5. Is this clear? This is called as associative law. Okay, come to the third one. A union with the null set. So beta suppose A is 4 and 5. Its union with the null set. Null means it is empty. So beta it will be A itself. A plus, it's like this. 4 plus 0 will be 4 itself. Na? So union of something with the null set is that itself. So beta this is called as law of identity element. Law of identity element. Clear? Next, fourth property. A union A is A. Just take an example. Beta A suppose 4, 5, 6 है. A, दूसरा 4 5 6 है बेटा। अगर मैं A का A से ही यूनियन करूंगी तो कॉमन एलिमेंट्स यूनिक लेने हैं ना, यूनिक एलिमेंट्स के साथ साथ सारे इंक्लूड करने हैं। सो यूनिक एलिमेंट्स अगर मैं लूंगी तो वो 4 5 6 ही आएंगे ना, which is just A. Beta, this property, this is called as idempotent law. That when you go ahead and you do the union of A with itself, you get A only. This is known as idempotent law. Okay. Fifth, U union A is U. Take an example. बेटा U is the universal set, सबसे बड़ा सेट, जैसे हमने यहां लिया था। सो यहाँ पे यूनिवर्सल सेट क्या था मेरा? यूनिवर्सल सेट सारे नेचुरल नंबर फ्रॉम 1 to 10 थे। जो मेरा A था, इट वाज ओनली द इवन नंबर्स 2 4 6 8 10, है ना। अब अगर मैं A और U के सारे एलिमेंट्स लूं तो U में तो सारे एलिमेंट्स वैसे ही आ रहे थे, A वाले। A was just a subset of U. So when I will find the union of the two things, when I want to include every element of A and every element of U, it will just be U na. I will, if I just write 1 to 10, A के तो सारे elements include हो ही गए, unique elements हमारे पास सारे आ चुके हैं। So this is actually a new property which I want to state, that beta whenever one is a subset of the other, then when you will find the union, then you will always get the bigger set. Are you getting it? Just for example, natural numbers are 1, 2, 3 till 10. Now my integer include negative and so on. Just infinite tak hai. My integers include minus infinity, minus 4, minus 3, minus 2, minus 1, 0, 1, 2 till infinity. So when I talk about integers, they are negative to positive, all numbers. When I include natural numbers, they're only positive. So beta, we know that natural number is a subset of integers. So if I ask you union between natural numbers and integers, तो इसमें negative और positive सारे include हो ही तो गए। तो अगर मैंने एक बड़ा set ही ले लिया, उसमें सारे बाकी elements automatically आ गए। I have included every element. So when one is a subset of the other, then union just means taking the bigger set. How do I show this in the Venn diagram? Beta, this is natural number. This is integer. Natural number is completely within integer. So when I find union, मतलब either A or B or both, तो बेटा ये तो पूरा का पूरा include हो गया ना, Z में ही सारे elements आ गए N के भी. So I don't have to include any separate element, right? So therefore I have included everything. Okay. So beta, what we were doing was the set theory. ठीक है जी. In set theory, we had already gone ahead and done first, what is set? How do you represent set? Then beta, we had gone ahead and we had talked about sets in set builder form and roster form. ये हमने कर लिया, ये पुराने lectures में available है. Then beta, next thing what we had gone ahead and we had done was, you know, what is finite set and infinite set. ये भी हमने कर लिया. Post that, we talked about equal sets in one of the classes, right? After that, we talked about subsets. And after subsets, in the last class, I also talked about closed and open intervals. And I also talked about Venn diagram and operations of set. ये सब हम पिछली classes में कर चुके हैं. We have already gone ahead and done all of this. But today I want to continue with this. And union of set हमने कर लिया था. And I want to go ahead and I want to go further with the intersection of set. तो यहाँ पे देखो, जो हमने last पढ़ा था वो union of set था और उसकी properties थी. आज जो हम पढ़ेंगे वो intersection of sets होगा. So please write down the next topic for today. That is intersection of sets. This is the next topic, intersection of set. Now, please understand. When I say intersection of set, I am interested in those elements which come in both A and B. So how do I write intersection of set? A intersection B will have those elements. इसको रोस्टर फॉर्मेट में मैं लिख रही हूँ बेटा, x such that x belongs to A and x belongs to B. So when we go ahead and we write x such that x belongs to A and x belongs to B, that is known as intersection. तो बेटा एक बार एक example ले लेते हैं. Let's take an example. So let's say that I have A and this A is 1, 2, 3, 4, 5, 6, 7, 8 and 9. ठीक है. And I have B and B are just even numbers, 2, 4, 6, 8 and 10. Now I'm asking what will be A intersection B. So A intersection B means those elements which will be in A and which will be in B. So what will I have? I have 2 in both of them. I have 4 in both of them, 6 in both of them and 8 in both of them. है ना? So I will get 2, 4, 6 and 8. This will be A intersection B. Now, supposedly you go ahead and you get that A intersection B is coming as 5. Sorry, यहाँ से not equal to हटाओ. It is coming as 5. That means A intersection B, it is coming as a null set. There is nothing common between A and B. How do I represent this beta in a Venn diagram? This is A and this is B. There is nothing common between them. इसको कैसे represent करते? This is A, this is B, and I have common elements 2, 4, 6, 8. So I have common between A and B. But suppose I don't have anything common between A and B, then beta in that case, A and B, they are known as disjoint sets. So when you don't have anything common between A and B, then they are called as disjoint set. I hope this is clear to you. There are some properties of, intersection also. Okay, so the first property, whether you do A intersection B or B intersection A, बेटा काम तो सेम ही कर रहे हो कि A और B के बीच का common part निकाल रहे हो. So whether you do A intersection B or you do B intersection A, you are doing the same thing, and this is known as the commutative law. Okay, beta. Second property. The second property says that if you do A intersection B, that means you find common between A and B. और जो भी common आता है, you find it's common with C. Or you find common between B and C first and then it's common with A. Beta, you will get the same answer. This is known as associative law. Okay? Associative law. Next property. Beta, third. If you find common between A and null, तो एक में तो कुछ भी नहीं है, उसका common A के साथ क्या होगा? कुछ भी नहीं, because null is null. So that will give you 5. Similarly, if you find common between universal and A, so beta imagine this, ये पूरा का पूरा universal है. This is entire is universe. और ये A है. तो A और universe के बीच का common part कौन सा है? यही तो common है जो दोनों में आ रहा है. So common between universe and A is A. These two are very important properties. Common between phi and A will be phi, and common between universe and A will be A. With a next property, fourth property. If I go ahead and I find common between A and A, that will be A only, na? दोनों same ही तो चीज है, तो A और A के बीच का common will be A. Beta, this is known as idempotent law. I hope this is clear. ठीक है. Now, एक बहुत important property है जो मैं आज सिखाने जा रही हूँ, and that is known as distributive law. ये ध्यान से समझो, ये intersection और union को combine करता है. The distributive law combines intersection and union. So you have A union B intersection C. A यूनियन बी इंटरसेक्शन सी, ठीक है, या उल्टा भी हो सकता है, सपोज यू कैन ऑल्सो हैव ए इंटरसेक्शन बी यूनियन सी, ये भी हो सकता है. Whenever you have intersection and union coming together, then the intersection distributes itself over the union. इसका क्या मतलब है? इसका मतलब ये है कि ये जो इंटरसेक्शन है ना, ये इसके साथ और इसके साथ लग जाता है. मतलब this is going to give you A intersection C union A intersection, sorry, A intersection B ले लो पहले, C. So it is going to distribute itself. That is what the question is saying. एक बार example देख लेते हैं. Suppose example. Beta A is 1, 2, 3, 4. Beta B is 3, 4, 5, 6. C is 5, 6, 7, 8. ठीक है जी. अब एक बात बताओ मुझे कि B यूनियन C क्या होगा? वो एलिमेंट्स जो B और C दोनों में आ रहे हैं, तो ये सारे एलिमेंट्स लेने पड़ेंगे. क्या क्या एलिमेंट्स हो जाएंगे बेटा? 3, 4, 5, 6, 7 and 8. ये हो गया मेरा B यूनियन C. अब अगर इस B यूनियन C का मैं A के साथ इंटरसेक्शन कर दूं, A के साथ इसके कॉमन एलिमेंट्स निकाल लूं, तो इसमें और A में क्या कॉमन है? व्हाट इज कॉमन बिटवीन A एंड दिस? बेटा कॉमन बिटवीन A एंड दिस विल बी 3 and 4. So this will be your final answer. अब रिवर्स करो. फर्स्ट ऑफ ऑल फाइंड कॉमन बिटवीन A एंड B. तो बेटा A और B के बीच में कॉमन क्या है? 3 and 4, है ना. फाइंड कॉमन बिटवीन A एंड C. बेटा A और C के बीच में कॉमन क्या है? कुछ भी नहीं. सो A एंड C के बीच में कॉमन क्या है? कुछ भी नहीं. अब इन दोनों का यूनियन कर दो. सो बेटा यहाँ के सारे एलिमेंट्स लोगे और यहाँ के सारे एलिमेंट्स लोगे. यहाँ तो कोई एलिमेंट ही नहीं है. सो आंसर हो जाएगा आपका 3,4. So please try and understand that you are getting the same answer. This is the distributive property. Distributive property क्या कहता है? That intersection distributes over union. ये जो intersection था, ये individually हर element के साथ लग गया. It has distributed itself over the union. I hope this is clear to you. Okay. Now let us go on to the next property, beta. So the next property that I have is this: difference of sets. That's the next property, difference of sets. Very important, beta. This can come in multiple exams, especially in CUET. Difference of sets is something which is very, very important. So let us go ahead and let us see. Now I am saying thank you, beta, for showering love on Artha Point. Thank you so much. Okay, so now we go ahead and we say A minus B. A minus B means what? A minus B means those elements which basically are there in A but not in B. A minus B. B के elements को you have to remove the elements of B. That is A minus B. So just have a look here, beta. I am saying A is 1, 2, 3, 4, 5, and 6. Beta B is going to be 2, 4, 6, 8. When I say A minus B, it means I will remove the elements of B. So how will I write that? X, such that X should belong to A. And I need to remove the elements that belong to B. So, but X should be removed if it belongs to B. Subtract those. minus, I can just put a sign minus, those elements which belong to B. So how can I go ahead and how can I write that? I am going to remove which elements beta? 2, 4, 6, and 8. So I will remove 2, I will remove 4, I will remove 6, 8 is not there. So A minus B will give me 1, 3, 5. Beta, can you quickly do B minus A? So B minus A will be those elements which are there in B, but not there in A. So how will I go ahead and how will I do that beta? So I am going to go ahead and I am going to, this was my 8. It should be there in B, but it should not be there in A. A wale elements will be removed. So A had 2, I have to remove 2. I'm subtracting A elements. 4 is there in A, I have to remove 4. 6 is there in A, I have to remove 6. So I will only be left up with 8. So B minus A will be 8. Very, very important property that I want to come to. The property is that beta A minus B is not equal to B minus A. Very important. You see, A minus B is coming as 1, 3, 5. You see, B minus A is coming as 8. So A minus B and B minus A are not equal to each other. They are different from each other. And this can again come in your CUET exam. So you have to be very sure that you understand this property well. The two are not equal. Let me show you this using a Venn diagram also better. So just think about this. This is A. This is B. When I do A minus B, I remove the elements of B from A. So I'm left up with these elements. I'm left up with these. But when I do B minus A, it means this is A, this is B. From B, I remove the elements of A. So beta, I am left up with this. Can you see that the two are not equal? A minus B and B minus A are not equal to each other. This is exactly what we are saying, that A minus B and B minus A are not equal to each other. Okay. Now, I want to pass a statement, very difficult statement, and you will tell me if this is true or not. So the statement I want to pass is the following. The set A minus B, A intersection B, and B minus A are mutually disjoint sets. You have to tell me whether this statement, that the set A minus B, A intersection B, and B minus A, whether they are mutually disjoint or not. Is this statement true or false? Let's see this better. So I am going to go ahead and I'm going to make this. This is A and this is my B. Okay, beta. What will be A minus B? From A, you remove all the elements of B. So you will be left up with A without B part. This is A minus B. Beta, what is A intersection B? Elements which are common between A and B. So elements common between A and B are these. What is B minus A? From B, you remove the A part. So B without A, which is this. B without A is this. So do you see that there is nothing common between the three? If there is nothing common, they will be mutually disjoint. So the statement is true. This is an absolutely true statement. There is nothing common between them. Okay, beta? Right. Now I want to talk about another concept here, which is called as complement of set. What is complement of set? Complement of set, which means it's represented like this. or like this, A complement. A complement means everything except A. So it is nothing but union minus A. A complement is union minus A. So I can say that A complement is all X such that X belongs to union and X does not belong to A. Those X's should not be a part of A. If I remove what X's belong to A, then I will be left up with A complement. Better let me go ahead and let me give you some question on this. So please write down the question. So my union is 1, 2, 3, 4, 5, 6, 7, 8, and 9. And my A is 1, 3, 5, 7, and 9. And I'm asking find A complement. So what will be A complement, beta? A complement will be A union minus A. So from the union, subtract what is coming in A. What you will be left up with, beta? 2, 4, 6, and 8. This will be A complement. So this is A complement. I hope this is clear to you. Okay. Now I want to come to an important property here. Let me just list that down. So what am I saying? I am saying that if A is a subset of U, then A complement is also a subset of U. क्यों बेटा? क्योंकि A complement U से ही तो निकला है. U में से जब मैंने A को subtract किया, then only I got A complement, ना? So A complements all elements belong to U. So it is a subset of U. Just think about this. This is A complement. What is A complement, beta? What A complement did I get? I got 2, 4, 6, and 8. Does 2, 4, 6, and 8 belong to A? Does it belong to U? Does it belong to my universal set? It does. So this implies that A complement is a subset of U. A is also a subset of U because A's all elements were there in U. So when A is a subset of U, A complement will also be a subset of U. That has to be there. Is this clear? Now, second property. Property number 2. Beta, A complement is A. When you go ahead and you find the complement of A complement, it will be A. Let us try this. Example. So my universal set, beta, is 1, 2, 3, 4, 5, 6. And my A is 2, 3. Beta, what will be A complement? A complement will be all elements except A. Matlab it will be 1, 4, 5, and 6. 1, 4, 5, and 6. Now I want to go ahead and I want to find the complement of this again. So when I go ahead and I find the complement of this again, that means I will remove these elements from the union. इसका complement निकालना है इस set का. तो ये set union से subtract होगा. So when I subtract 1, 4, 5, and 6, I will be left up with 2 and 3, which is nothing but A. So A complement's complement will be A itself. I hope this is clear to you. Next property. This is known as De Morgan's law. De Morgan's law. क्या कहते हैं De Morgan's law, बेटा? A union B complement is equal to A complement intersection B complement. And A intersection B complement is equal to A complement union B complement. Let me give you an example to this. So, question. So beta, your union is 1, 2, 3, 4, 5 and 6. Beta, A is 2, 3 and B is 3, 4, 5. First, I will try this. First De Morgan's law. So can you tell me what will be A union B, beta? A union B means all elements in A and B. So you will get 2, 3, 4, 5. If you have to find its complement, it means from union, you will subtract this. Union mein se isko hata do. So what will you get? You will remove 2, 3, 4 and 5. You will get beta 1 and 6. ठीक है जी. अब ये देखो A complement क्या होगा बेटा? What will be A complement? Everything in union in the universe except A. So you will remove 2 and 3. So you will get 1, 4, 5 and 6. Beta, what is going to be B complement? You will remove everything from universe where B is present. So you will remove 3, 4 and 5. So B complement will be 1, 2 and 6. Now find the intersection between these two. A complement intersection B complement will be beta 1 and 6, because only this is common now. 1 is coming common and 6 is coming common. So we have proved the De Morgan's law. We have proved that A union B complement is equal to A complement intersection B complement. But a second one, I want you to try on your own. And what I will do is I will show you through Venn diagram. So see this. This is A. This is B. This is universe. A intersection B means common between A and B. That means this. Now, when I have to find its complement, it means everything in the universe except this. Iske alawa sab kuch universe ka. So everything in the universe except this means beta all of this. All of this. Except this. This is your final answer. ठीक है, अब इसको solve करते हैं. बेटा, this is A. This is B. This is universe. What will be A complement? Everything except A. This is A complement. What will be B complement? Everything except B. Because this is B complement. Everything except B. Now you have to find union between the two. Union mane you have to take every element coming in these two sets. Every element. Common nahi lena, union lena, har element lena. So beta, every element coming in these two sets will be everything that has been highlighted. That means entirety of this except the intersection part. But this and this are coming as the same. जो यहाँ shade हुआ, जो वहाँ shade हुआ, वो तो same ही है. So again, we have proved the De Morgan's law that A intersection B complement is equal to A complement union B complement. I want you to try this using this example also, just like I proved this part. Okay. Now, I want to go ahead and I want to write all the properties of complement sets. So properties of complement sets. Okay, beta. The first property is called the complement laws. This property says that A union A complement is universe.
ध्यान से समझो बेटा, दिस इज यूनिवर्स, दिस इज ए. What will be complement of A? Anything other than A. This is A complement. Now, if I do union of A with A complement, won't I simply get everything here? That means I will get the universe, right? Second law. A intersection A complement is null. बेटा फिर से देखो. This is my universe. This is A. What is A intersection? Everything other than A. Everything other than A is A intersection. Right? This is A. Is there anything common between the two? Nothing, na? So I will get the pi set. De Morgan's law. I've just explained you this. I'm just writing this. A union B complement is A complement intersection B complement, and A intersection B complement is A complement union B complement. I've proved these. Next बेटा, ये भी हमने प्रूव कर दिया है, law of double complement. I've already proved this. What does this say बेटा? A complement is A. When you go ahead and find complement of A, that is A itself. Okay. At last property, it says null ka complement. This is called as law of empty set and universal set. Complement of null is universe and complement of universe is null. क्योंकि universe में सब कुछ include है, तो अगर मैं universe से universe से हटा दूंगी तो null ही बचेगा ना. So complement of universe is null and complement of null is universe. I hope this is clear to you. Look at the first question, beta. Write A in the set builder format and 4 options are given to you. I am giving you 1 minute to solve this. Quickly try to solve this question on your own. You have A given to you and you have to write this in the set builder format. Just have a look, beta. A is 1, 4, 9, 16, 25. तो ये क्या बन रहा है? स्क्वायर बन रहा है ना? 1 square, 2 square, 3 square, 4 square, and 5 square. ऐसे बन रहा है ना? So what should A be? A is such that A is square of natural number. So the correct answer to this question, I hope all of you have marked it correctly in the test. It should be A. A is the correct, it should be C. C is the correct answer to this question. Okay, beta, come forward, come to the next question. Beta, if A, B, C are 3 sets, then A ka cardinal product with B union C will be. So beta, this cross product, it follows distributive property. It follows distributive property. Distributive property का क्या मतलब है? मतलब I can distribute this across unions. That means A cross B union C will be A cross B union A cross C. So you can go ahead and follow distributive property and you can distribute. I hope this is clear to everyone. So answer will be, the correct answer is A. That's the correct answer. ठीक है जी? Better come to the next question. Number of elements in A is 3. Number of elements in B is 6. A is a subset of B. Number of elements in A intersection B is equal to. Better it says A is a subset of B. मतलब जो भी A में है वो B में होगा ही होगा. So something like this. Better I can say A is 1, 2, 3. Better B is 1, 2, 3, 4, 5, 6. क्लियर हुआ? बेटा क्लियरली दिख रहा है ए बी का सबसेट है. ये भी दिख रहा है कि ए में 3 एलिमेंट्स हैं और बी में 6 एलिमेंट्स हैं. तो बेटा कैन यू टेल मी व्हाट विल बी A इंटरसेक्शन B? व्हाट इज कॉमन बिटवीन A एंड B? ऑल दीज थ्री एलिमेंट्स ना, A B 1 2 3 ना. सो ये A इंटरसेक्शन B में A के सारे एलिमेंट्स आ जाएंगे क्योंकि ये A में भी हैं और B में भी हैं. So better then what will be number of elements in A intersection B? We are clear, ma'am. It should be 3. So answer to this question is 3. That's the answer to this question. Okay. Come to the next question. Better next question dekho. If R is this, then the range of the function is. Ye actually thoda sa out of out of course हो गया. Out of course माने range is the second chapter बेटा. तो range मैं भी पढ़ाऊंगी. I haven't taught you range yet. I will be teaching you in the next chapter. But as of now, एक चीज समझो जरा बेटा. ये कहता है कि 2 को हम 1 के साथ मैप कर रहे हैं. 2 is connected to 1. हाँ बेटा 4 is connected to 3 and 4 is connected to 5 also. ठीक है बेटा. तो बेटा ये जो हो गया हमारा, ये जो है हमारा, ये हो गई हमारी रेंज. ये एक तरीके से हो गया हमारा डोमेन. तो when we have to find the range of the function, it has to be this side. But I will do this in my next classes. हम chapter number 2 में ये पढ़ने वाले हैं. So as of now, the correct answer to this should be B. ठीक है बेटा. Come to the next question. Let U represent the universal set. A is 1 2 3, B is 6 7, then what will be A intersection B? तो बेटा बहुत सिंपल है. A ये है. A में कौन से एलिमेंट्स आ रहे हैं बेटा? 1 2 5. अच्छा B कॉम्प्लीमेंट लिखा है यहाँ पे, ध्यान से समझना. सो बेटा B में कौन से एलिमेंट्स आ रहे हैं? 6 7. तो B कॉम्प्लीमेंट क्या होगा? यूनियन माइनस B. तो यूनियन माइनस B जो है ये A है. यूनियन माइनस B क्या हो जाएगा? एवरीथिंग इन द यूनियन एक्सेप्ट B. B के अगर एलिमेंट्स में हटा दूं, अगर मैं 6 7 हटा दूं बेटा, तो क्या मिलेगा? 1 2 3 4 5 8 9 10. ये B कॉम्प्लीमेंट हो गया. अब ये कह रहा है A एंड B कॉम्प्लीमेंट का इंटरसेक्शन. व्हाट इज द कॉमन बिटवीन द टू थिंग्स? बेटा 1 इज कॉमन, देन बेटा 2 इज कॉमन, देन बेटा 5 इज कॉमन. तो जब मैं इन दोनों का कॉमन निकालती हूं तो आंसर आता है 1 2 5. बट ये 1 2 5 तो सेट A ही है ना. दिस इज सेट A ओनली फॉर मी ना बेटा. सो आंसर टू दिस क्वेश्चन विल बी दैट आंसर विल बी सेट A. आई होप दिस इज क्लियर टू यू. I am again repeating that all these questions are available on our app Artha Point. You can download this app. There sir will give you access to free study material and you can get that material. Okay beta, this is very useful for all your entrance exam, even for your CUET entrance exam. Okay beta, let us go to the next question. बेटा नेक्स्ट क्वेश्चन में क्वेश्चन नंबर 10 ले रही हूं. तो 10th क्वेश्चन देखो अब जरा. इट इज सेड दैट x minus 1, y plus 1, this is given to you as 5, 6. बहुत ही सिंपल क्वेश्चन है. इट इज आस्किंग व्हाट विल बी x एंड व्हाट विल बी y. सो बेटा आई विल कनेक्ट दिस टू दिस. सो इफ x minus 1 is 5, then beta x will be 5 plus 1, that means x will be 6. And beta if y plus 1 is 6, then y will be 6 minus 1, that means y will be 5. So the correct answer to this question should be 6, 5. That means the correct answer is B. ठीक है बेटा. Come to the next question. A and B are two sets, then what will be this? बहुत अच्छा क्वेश्चन है. देखो when I say A union B complement, union A कॉम्प्लीमेंट इंटरसेक्शन B, इस पूरी चीज की वैल्यू निकालनी है. तो बेटा क्या कर सकते हैं हम ना ऐसा कुछ बना सकते हैं, एक वेन डायग्राम. बेटा दिस इज A, दिस इज B, देन A यूनियन B क्या होगा? व्हाट विल बी A यूनियन B? A यूनियन B विल बी दिस. एवरीथिंग इन A एंड एवरीथिंग इन B, A यूनियन B हो जाएगा. देन बेटा A यूनियन B का कॉम्प्लीमेंट क्या होगा? everything in the universal set except A union B. तो माने ये आ जाएगा आपके पास. This will come. Let me mark this. ये येलो सेट आ जाएगा सारा और ये हट जाएगा. This is A union B complement. ये वाला पार्ट सॉल्व हो गया बेटा. अब देखो A complement क्या है? Everything other than A. तो इसको जरा हम देख लेते हैं. Everything other than A क्या हो जाएगा बेटा? अगर मैं एक अलग डायग्राम में दिखाऊं आपको, फिर से ये A है, ये B है. Everything other than A. Other than A मतलब ये सब. ये हो गया एवरीथिंग अदर देन ए. अब नेक्स्ट बोल रहा है इंटरसेक्शन विद बी. इसका कॉमन एरिया बी के साथ कौन सा आ रहा है बेटा? ये वाला. यही वाला तो इसका कॉमन एरिया आ रहा है ना. यही तो कॉमन एरिया आ रहा है. तो जो अगर हम इंटरसेक्शन निकालते हैं तो जो कॉमन एरिया आ रहा है बेटा वो ये आ रहा है. अब इस सेट का ये हमारा हो गया बेटा ए यूनियन बी कॉम्प्लीमेंट. And beta, this is A complement intersection B. You need to find out what is the union between the two. So union means you will take everything in this and everything in this. That means you will include this part also in this now. This is only the extra part that I get from second one. So when I solve this entire thing, what am I getting? My answer is nothing but the entire universal set. Entire universal set. Except A. A के अलावा everything is highlighted. Except A, everything is highlighted. So you will have the entire universal set except A. So beta, this is nothing but A complement. That's the answer to this question. So answer should be 9th. For 9th, it should be A. I hope all of you marked this correctly in your test this morning. The answer will be A. The test is available free of cost on Artha Point app. For students who haven't attempted the test, please attempt it from our application. Come to the next question, beta. Which of the two sets are equal to each other? Okay. Equal means elements of A should be in elements of B and elements of B should be in A. So if A is a subset of B and B is a subset of A, then beta, we have already done this in class. A and B are equal. Please refer back to my lectures. ठीक है जी. So beta, equal sets कहाँ दिख रहे हैं हमें? This also has 1, 2, 3. This also has 1, 2, 3. So C is the correct answer to this question. These two are equal sets. Is this clear? Okay, beta, come to the next question. How many rational and irrational number between 0 and 1? Very good question. It can come in CUET for sure. So the number of rational and irrational numbers between any two numbers, beta, they are infinite. I cannot count them. Example, this is 0, this is 1. Beta, I can have half also. I can have 1 by 4 also. I can have 1 by 3 also. These are all numbers between 0 and 1. Na? Then I can have 1 by 22 also, 1 by 23 also, 1 by 100 also. ये सब 0 से 1 के बीच में आएगा. I cannot count those numbers. They are infinite numbers between 0 and 1. है ना? So the answer to this question, beta, it will be infinite. At last, question number 6, beta, I will again say that this is out of syllabus for now. I have only covered set theory with you. ये actually chapter number 2 है. ये हम next Monday से start करेंगे. We will start this from the coming Monday. But for now, I will just try to solve this for you. But I will do this in class from next Monday onwards. So beta, it is given y is equal to 3x minus 2. To find the range, you will write x as a function of y. So beta, x will become y plus 2 by 3. X will become y plus 2 by 3. Beta, y can take any value from minus infinity to infinity. Y की कोई भी तो value में x की एक value आएगी. There is no restriction on the value of y. So the answer to this question will be A. Y can take any value from minus infinity to infinity.